Hello everyone, this is Atif again. In this tutorial I will talk a very important module which I call is batch file maker and BNDF to OpenFIRE. This is BNDF is the one method to extract data from FDS, but how to take this data from FDS I will explain you in this tutorial, and how to make in a format of OpenFIRE, which I discussed previously in previous tutorial. You will see how we data transfer from device approach, where we put on particular device to calculate some like adiabatic surface temperature, heat transfer coefficients. So how we can get data from different methods, so which I will explain to from my window machine. So sometimes what you do when you are doing FDS, we fix these locations. Like I want temperature at this location, I put the device at particular location. So but if your structure engineer says that I want temperature at different location, I don't want here, I want something here, so what are you gonna do? You have to do simulation again. But if you don't want to do what, you can say what I want to do, I want to calculate all this temperature on this surface or solid surface, then I will get it. So all, or you can take any means gas temperature within all cells, and this thing, though it's computationally very expensive, but you need not to do simulation again and again if you need temperature data from other place. So there is a method for this in FDS, you can do that one. So which is they call is BNDF. So let's check 1 minute this one. So like for example, I have to calculate like adiabatic surface temperature, so I will say ampersand BNDF and adiabatic surface temperature. So it will calculate this value or all solid surfaces, and BNDF quantity, heat transfer coefficient. So once you simulation, then you can extract the data by yourself by assigning the location, by assigning similar location like XYZ and orientation of the device you come. So I will try to explain you with this example itself for this column which is exposed to fire with the pool fire. So I have already finished the simulation. So this is I will do this is validation test. So once you finish the simulations, you will get a lot of data like this. So this is my FDS file here, same file. You can see I adiabatic surface BNDF quantities made this one. So once you finish, so you will get like assembly file. Assembly file is the one where your data is the output of your simulations. So this is my file, which is so how this data is saved in these situations. So data is saved in a boundary file. So if you see the bunch of files are here, so which data is saved there. So this data, let's see how this data look like this. This is in binary digit, so you cannot extract the temperatures or anything because in binary it's so but FDS comes with one software with this package is called FDS 2S key. So it can convert data in integers. Let's see how it does. So let's go to git bash here. So this is the bash where you can use. So I'm using here, so I will suggest you to use this git bash or some anything where you can, or any bash program where you can use Linux commands. So let's see this how to calculate FDS 2S key. So enter the job name. So this is your assembly file name. My assembly file name is validation BNDF. So this is, you need not to put .smv, actually it's reading assembly file. So where you want temperature, plot 3D mean when you're taking gas temperature, so this is calculating at all control volumes the quantity which you want. Slice when you have one two-dimensional slice when you can take temperature. BNDF is usually basically for solid surface. So basically we are taking temperature of the solid, so we go 3. So sampling factor for data, I take data for all data. So my domain size is limited. I want particular location temperature, so I say y, yes. So I have to give the minimum, maximum, x and y, z. So for example, if I see here my for C I want to take on the front surface, so here is my geometry, like 0.4 is x, my y between is 0.17 to 0.27, and my z is up to 1.6 meters. So what I want temperature somewhere here, for example 0.4, 0.22, somewhere here I want temperature, adiabatic surface temperature here. So I will give here 0.4 to point, because my mesh size is point, so I will give, so it will take temperature within this mesh size, 0.41, 0.22, 0.23, 0.3 I want, 0.31. So now it will give, this is important to notice. For the here I show you FDS file, I was calculating two quantities, adiabatic surface temperature and heat transfer coefficient. So this is showing the mesh. So here I have like 6 meshes here. So 1, 2, 3, 4, like for example I have like 6 meshes here, 1, 2, 3, 4, 5, 6. So it is showing me these 6 values, 6 mesh, but this mesh number is different for each quantity. So mesh 1, 2, second 3, but it is showing that first, so the first mesh is with first at the lowest position here. So this is very important to, otherwise you will not get quantity which you measure. So this is my mesh 1, mesh 2, mesh 3, mesh 4, mesh 5, mesh 6. So you have to remember that. So this is my 0.3 is in mesh 2. Okay, so it's in mesh 2, but I'm checking adiabatic surface temperature, so my mesh index is 3. But if I'm taking adiabatic surface temperature in the third mesh, then my mesh index is 5. So how we have to use, I will tell you. So here, and within what time period you want to average your data. So FDS average the data within 2 time. So I say 10 to 20. Within this 10 second I want to average the data. Orientation of device, which if you go to my previous video of the device and elements, I tell you this, the what is orientation means. It's +1 to -3, 1, 2, 3, and -1, -2, -3 depends on the direction of the coordinates. So here I take -1, it's negative x direction. Number of variables, I want to calculate only adiabatic surface temperature, so I say 1. And what is the boundary file index, means what is the mesh index. I'm calculating my 0.3 something, 0.3, and above just 0.3 is in mesh 3, means mesh 3 in mesh 2, but mesh index is 3 for adiabatic surface temperature, so I give 3. And then output file, what the output file, I say test.csv. So you see the one that CSV is saved here. So within these places, within 10 to 20 seconds, the average temperature I got 512. So it gives bunch of other data also, which I don't need. I need this, but I have to make this data in OpenC's format. So I need, so here you see, to make this, it's very, you cannot do for each 10 second, 20 second, 30 second. You have to do repeat this process, like it will take like days and maybe months to do if you have a very large structures to do, take data. For if your fire is like 3 hours, 4 hours, so every 10 seconds. So this one, so but the good thing is that this, what I'm gonna do here, we will make a batch file so that it can run here. So let's do how to do that. Let me delete this. Okay, so pin So let's do this. So here we go. So this is batch file maker. So it is how I'm going to make batch file from this program. I will give you the link of my GitHub or my website below this video, so you can go and download this software from there, this Python program, and you can change it according to your need. So let's see, I run here, so it will give my this GUI. So first I will go to the directory where this my file is saved. So I'm already there, this folder where my SMB file is saved, and I have to give my SMB file name is validation pndf. And I like in reality you have a temperature would be very high, like 1 hour, like 3600 second or something. So but in this, for example, I will say like 300 second, and I need a temperature time interval for every 10 second. Mesh index, which I already showed you, it's in the mesh numbers. And mesh size, you have to define what is my mesh size is, so that I can know that within this range it will search. So here I will say my mesh is like 0.2. okay, so here I give my mesh size. So I want to, because it's a column, so in one front of column I want to take data. So my X was, let's see here, you must know that your solid boundary should be there, otherwise you will not get any data. So as I say, it's at 0.4. So I put like here 0.4, and my Y is, because I'm taking 0.7 to 0.22, so it's 0.22. And initial I take like 0.3, and total height 0.6, and I want one data for every 0.1 meter distance, and orientation, as I told, is -1, and its mesh index, first 0 to 0.3 is mesh 1, and then 0.3 to 0.6 is mesh 2, which is for adiabatic surfaces temperatures mesh index become 3. So this is how I'm going to this data for the columns. So I generate this file. If you go there in this folder, it will create one file. This is batch file. So you can see it create this file. So where I can need not to put data, it's create how much data I need. Now I want to put 3 more devices for unless above another mesh index. So this mesh index is my 5 next, because next mesh will come next. So 2 is added because between it with heat transfer coefficient. So adiabatic surface temperature is the only thing which we are calculating here. So here my minimum initial Z is 6, and then it's 0.9. Then it will increase the length of my like you say that it will create here. So now how many devices I have? Every 0.1 meters, so 0.3 to 0.9, I have like 6 devices. So I put at 6 location I need the temperature data. So how to run it? And it's very easy. So let me stop this. So you go to that folder again, where so first you have to change this format into the command. So because I want to run as a batch. So when you are using Windows, usually command window, so you use batch file, the BAT. But when you are for Linux and Unix, you have to use command file as a batch file. Batch file is called command file here. So how can I run here? Just go to bash here, and here use chmod +X. I don't know why my keyboard is not working. +X batch file dot command, and once you're done, you go dot / batch file dot command, and you see it's making a lot of CSV file. So for example, I did 6 for 30 seconds, or 300 seconds for each 10-second difference. So it makes 6 devices for 30 files for each device. So you can see it create like 180 files for me. For example, now you have a lot of data. Then how can you do that when you, for 306 means you have like 2 hours file, so it will create a lot of files. So how to control it and make in OpenC's format? So for this one we have another code here which is also added within this one. I said BNDF to OpenC's. It's also very simple code, you can download also. So here you go there, you run here, so it creates here. So here you have to go to the same directory because my files, all these, the data is saved there. Then assume my time of simulation was 300, and every 10 time interval I need 10. So how many devices I have? I had 6 devices, like every 0.1 meter, and then I save it. So here is save. When you save it, it makes one folder is OpenC's. So it is, see, it created data for me in the format which you see in the device. So every 10 seconds you can see, every 10 seconds it's giving me temperature 270, 77, like this. So for at 0.1, this is at location at 0.1, 0.3, sorry, and this is at next, and this is at the 6th location. So this is how you can get data in the format of OpenC's. This is how the batch file and BNDF to OpenC's, they together can give you the data in the format you required. Okay, so that's all for here. This BNDF to everything, it's a very amazing, very small program, but it's very amazing, and you can change it for when you are using for slice and you want to take gas temperature when the plot 3D. So you have to just change one number which I will say you here, like in that's my code. I like here I can change in from there, but I really did not want, because in this case, like here, variable 1, yeah, for BNDF I say for 3 I'm using, because I'm using at the 2 for slice data, plot 3D is for 1 here, this is 2 for slice data, 3 for BNDF data. So this is how program is running. So it is making batch file. This is for IJs for the slab, if you are doing slab, if you are making a truss, so it will create in a separate way. So you can choose this program, you can change here. So here one function which is creating this batch file for you for different time period. This is for columns, that for each until this column it is a loop which is running with the Z length. Similarly for beam, it's along the length and along the width trusses, and for slab in all both direction, X and Y, it can create your BNDF file similar to the device and element we created. So maybe later I will add so that you can do for structure elements for BNDF file as well if you want to search elements at there too. So, and then once you, this is for the batch file for BNDF to OpenC's is also very simple. Here just you have to provide that how many I just provide the folder name where data should be, and there's some temporary folder where the data was saved. So what is important here, I need to tell you guys, here I create the temperature, I make a list. This is important, I make a list of all elements, so it will, the list is that it is equal to the how much file it will come, that will be equal to the time into number of devices. That's why I put here number of devices. So simulation time into number of devices and divided by the time interval, like 30, I have 300 total time, divide by 10 is 30, and multiply by number of devices. So this is, I have total number of devices, so total number of files. So it will make a list of all files, so all file lists are there. So at one time it will take how many devices are live for 30, for the 30 device it will connect in one file, another 30, the similar way it will run, and it will make this this file for you. So that's all for this tutorial. I hope it will be helpful, and if you have any question you can ask, and if you want to change it you can go to my GitHub account or my website, which links I give below to this in the description of this video. Thank you very much for listening, and I'm glad that I was able to make this video and this programs for your easiness.